often give people trouble. Exponentials often give people trouble on the test, so make sure you're okay with all these. All right. Population of a certain country doubles in 28.88 years. Find the growth rate K. Assume the population increases exponentially. Give an exact answer, not a decimal answer. All right. We're talking PERT again, right? Whenever we have populations increasing, decreasing, money increasing, decreasing continuously, that'd be PERT formula. Okay. Let me give you just a second. Population doubles in 28.88 years. Oh, when they say growth rate K, they mean R. R, K, it's all the same thing, right? They mean what you have right there. The book called it K. I think the book called it K. I called it R, whatever. The growth rate is R. Huh. You can call it K or you can call it R. It's all the same thing. So find the R. So basically they're just asking you to do phase one. Is what they're saying. That's what we do in phase one, right? It's find R. So go ahead. Let me give you a second. So what do we do? Certain country doubles. Population doubles.
2p equals
Yeah. The A is 2p. Right? It's twice whatever the original population. Because P is the original population. It's the original principal investment if it's money, right? So doubles means 2p. Right? We good? Okay. What do I do next? I got to solve. Oh, it doubles in 28.88 years. I'm supposed to put that in for T, huh? 28. So in 28.88 years, the population doubles. A becomes 2p. All right, yeah, so now we need to solve for R. What do we do first? Yeah, divide by the p. Gonzo. So 2 is e to the r, 28.88. What are we going to do now? ln again. ln to the rescue. Right? ln on both sides. The power comes down. So that becomes, bring it up here now, that becomes ln 2 is r 28.88, ln e, which is 1. So ln 2 is r 28.88. Last step, divide by the 28.88. Boom, there's r. Somebody got that?
I don't think that guy.
Oh, they just want that. Okay, we'll just leave it like that. There we go. Questions on that one? So it was just do phase one, huh? Normally they would follow that up with a second thing and say, all right, so how much after 50 years or something like that, right? But they didn't. They just had us do phase one.
Are you going to add those tricky ones where they start off with like months and then go to years?
Oh, maybe. I honestly don't even remember, to tell you the truth. I try not to do that, but there might be one slip by. I just grab them off the publisher's website. That's how I'm making my test. My test has come off the book publisher's website. I just say, I ask it, there's a test generator. I say, give me one exponential. Give me one parabola that where you give the focus and not the, I tell it the types I want, but it picks the particular numbers and stuff. So maybe, probably not. I try to avoid. All right, number 4. How long does it take 1,700 to double if it's invested at 5% interest, compounded monthly, round your answer nearest 10th? All right, formula. It's at the top, right? Remember the formula? I gave it to you right at the top of the practice exam. It's up there. A equals P, 1 plus R over N to the NT. How do I know it's that formula, not the PERT? Yeah, because the compounding is monthly. Anything other than continuously, right? The only time we use the PERT is for money problems if it's compounded continuously. And then we always use the PERT for populations growing and shrinking and stuff. Exponential growth and decay. All right, so here we go. How long does it take 1,700 to double? So the original P is 1,700 and the amount is 2 times 1,700. A is 2 times 1,700 or 3,400. Right? We good there? Is that making sense? All right, so that means 3,400 is 1,700. 1 plus R, what's the interest rate? 5%. In, what's in? Yeah, monthly. In is 12. To the 12, and what? And T is what we're looking for, huh? They said how long? Okay, so you're with me to there. You're with me to there. Questions so far? All right, so now how do we solve that for T? Everybody good to there, right? They said $1,700, that's the initial investment, P, the principal. You want it to double, 2 times 1,700 is 3,400. You want the amount to become 3,400. Can you read all that up there? I'm going to try to make the pencil a little smaller so it can squeeze it in. Times 1,700 is 3,400. All right, so good. Now we got to solve for T. Can you solve that for T? What do we do to solve that for T? Yeah, let's start by dividing by the 1,700. Very good. Divide by the 1,700. That's 2 equals. So 2 equals 1 plus 0.05 over 12 to the 12t. Now what do we do? Yeah, because the letters in the power. Right? Natural logs are what get letters out of the power zone. So I'm going to do the ln of both sides, ln, and then the power comes down, right? That's the big step. So ln 2 is 12t, ln of 1 plus 0.05 over 12. Good so far? ln of both sides, got that out of the power. Now last step is divide. Divide by everything other than the t, so that we can get t alone. There we go. T's alone. Hit the buttons, whatever that thing is. Somebody got it? 13.9. Oops. 13.9? All right. T equals. Anybody else getting that? 13.9 years, months, years, huh? Years. 29 years. Make sure you can do that on your calculator. Make sure you can hit the buttons on this and get 13.9. That's a 12 there. Questions on that one? Very good. All right. I'm going to move along. You got that copy down? Move along. Fresh screen here. All right. So... whoops, marking it up here. So Cindy will require, wait, where's the problem here? Here we go. Oh, we just did that one. Okay. So let's do this one now. Cindy will require $13,000 in 4 years to return to college to get an MBA. How much money should she ask her parents for now? So that if she invests 11% simultaneously, enough money for school. What formula? PERT. How do we know? Compounded continuously. PERT. So I'm going to come up here. Get number 4 out of the way here. So it's for number 5 up here. So we're going to use PERT because it says compounded continuously. Cindy will require $13,000 in 4 years. Will require. Is that the amount she's putting in? It's the amount she wants later. She wants to put some lower amount, call it P, the principal, in now and have it turn into $13,000 in 4 years, huh? Right? And the rate is 11%. The time is 4 years. Find P. Find the principal, huh? Good there? So do I have a letter? Do I need to do natural log on both sides? No. Everybody see why not? Yeah, there's no letter in the power zone, is there? We only do, now what's natural log for? It's for bringing letters down from the power zone, huh? We don't have any letter in the power zone, we just have numbers. So just divide, right? This is just a simple divide. Just divide both sides by E to the point 11 times 4, e to the point 11 times 4. Boom, boom. Get your solution for p. Somebody got it? What's p? It's something lower than 13,000, right? Some 10, 11, 12. 8? Wow. 8,000, what's that?
372.
372. Wow. That's pretty good growth. 11% over 4 years. That 8,000 whatever will turn into 13. Wow. We good? Questions on that? We happy? All right. Okay. Artifact discovered, certain site. If it has 60% of the carbon-14 it originally contained, was approximately age of the artifact. Carbon-14 has a half-life of 5,600 years. All right. Now I can do it long way, but I did give you a shortcut. Remember the shortcut? The shortcut for half-life. It'd be beneficial to write this on your 3x5 card. What's the shortcut I gave you for half-life? You can just simply write A equals, wasn't it, I forget now. What was the shortcut? It was like a 0.5 to the t over the half-life. But wasn't there like a p in the front, I think? Yeah, I think it's that. I'm pretty sure. We'll work it out and we'll see. Otherwise, I'll take it all back. I think that's it. I think that's the shortcut. So write that in your 3x5 card. See, I really don't have a good memory. I'm not kidding about all that stuff. I don't remember, but I think that was the shortcut. We could come up, we could do it the long way and find it. But this would be nice to save yourself a little time on the half-life problem. Assuming there is one. There probably is one on the exam. Almost for sure. So, see, the 0.5 is the half. 0.5 is the half. So, you just say, all right, A equals P. 0.5, what is the half-life? 5,600. Like that. All right? Now, what do we do? It says the artifact is discovered at a certain site. It has 60% of its carbon-14. Give you a second on that. What do you do with that? Yeah, 60%, they're telling you the amount is 0.6 of P. Or yeah, you could just make P1 and A.6. Technically, it means 60% of the original, right? Times the original. Does that make sense? They're saying it has 60% of its original amount. 60% times, of means times in math, right? 60% of its original P, 6.6 times P. So there we go. Solve for P. So this, with that shortcut, these half-life ones will be easier than the other ones. How do we solve there? For T, we want to know T, right? How old the thing is. Approximate age. What do I do to solve for T? Yeah, get rid of the P on both sides, right? Just divide by P. So yeah, you guys are right. Then it's going to be an ln here in a second, huh? So it becomes 0.6 is 0.5 to the T over 5,600. And sure enough, our friend, the natural log. The power drops down. Power drops down. Bring it up here. And you get ln 0.6 is T over 5,600. ln 0.5. We good to there? The power came down to the front. So far, so good. All right. Now, what do we do to solve for T? We're going to get that T alone. We could divide off the ln 0.5 on both sides, for starters, if you want. And we'll get ln 0.6 over ln 0.5 is T over 5,600. Good to there so far? I just divide the ln 0.5 on both sides. Last step to get T alone? Multiply by the 5,600 on the left side and the right side. Boom. So T equals ln 0.6 over ln 0.5 times 5,600. Yeah, I believe that's right? What's the answer there? 4,127. Is that the answer on the key? Is that what it says at the back there? Make sure I didn't give you the wrong shortcut formula. That's it? Good. All right. Don't need to take back anything. So yeah, use this shortcut for the half-life problems. You notice we skipped phase 1. Normally with the PERT problems, we got to do phase 1 and then we got to do phase 2, right? So I'm saying for the half-life problem, I'm giving you the shortcut for phase 2. You can just jump right to that little formula. Questions on that? You good? All right. So you'll need, this is part 2 that we're working on right now. You'll need to do all of part 2. That'll be next Tuesday, 50 minutes. All these questions, part 2, 50 minutes. So you want to be kind of quick, so I would use that half-life shortcut, for example. You're going to want to have a speed. You can't be, there is plenty of time if you know what you're doing. If you just like look at these questions and just whip them out, you know, there's plenty of time. But if you like look at them and you like have no idea and you're like trying to recreate the wheel for the first time, yeah, that's not going to happen. You're going to use up all kinds of time. And you always want to move fast with tests, right? To the things you know. Do the things you know first. All right. So can you solve that one? E to the 2x equals 7. Try that one. Solve for x. It's just solving. Is all it is. E to the 2x equals 7. So try that. So what are we going to do? What are we going to do? Oh, I guess you could. Solve this. Use a calculator to obtain a decimal approximation correct to 2 decimal places. Yeah, I'm just thinking, what do we normally do when x is in the power zone? Just ln. Just do ln on both sides. Yeah. And then, right, ln on both sides because the letter's in power, right? And then the 2x drops down. 2x ln e. ln 7, that's a 1. So 2x is ln 7. Last step, divided by 2. Boom. Yeah, make sure you can do that by hand as well, because I might ask you to not give me a decimal. I might say, hey, give me an exact answer. So you'll need to, be able to do it by hand if I say exact answer. So there's the exact answer. What's the decimal? 0.97. 0.97. There we go. Good? All right. How about number 8? Try number 8. All right, what am I going to do on number 8? X's are in power. Yeah. This is like a broken record, huh? When x is in power, ln. So you really see now why they made up natural logs, or logs in general, is because it takes powers down, and thus it's very useful. Oops. Everybody good to there? Now, a lot of people are good to there, but then get all stuck. All right, we good to there? Why did I put parentheses around that x plus 6? Is that really necessary? What if I just wrote x plus 6, no parentheses? Why is that actually wrong? Not just a visual thing, but a wrong thing. Because then only the 6 is multiplying the ln. That means x alone added to 6 ln 5. That's what it means if there's no parentheses. So only the 6 would be multiplying the ln 5. And that's wrong because the whole x plus 6 was in the power. Thus, the whole x plus 6 comes in the front to become a multiplier, not just the 6. Right? So you have to have those parentheses or you've changed the meaning incorrectly. All right. So anyway, so what? Now what do we do? How do we solve for x? A lot of people get stuck on this one. No, we don't want to do that. Yeah, let me do that and show you why that. Don't write this down. If I divide by ln 5, then I'll get x plus 6 is x ln 7 over ln 5. Then what am I going to do? Subtract the 6, but then x is not alone. You see the problem? X is in two places. Our main problem here is that x is in two places, right? So instead of that, what we're going to do is just distribute this ln 5, right? Get x ln 5 plus 6 ln 5 is x ln 7. So first get them separated. Now we have three terms, and two of them have x's, don't they? We have three terms, two of which have x's. This is a common theme. You'll do this a lot in calculus, in 5A. What do you do when you've got three terms and a couple of them have x's? Get those two on the same side, factor out and divide. So let me write that. When two x terms, get them on the same side, factor out x and divide. So that's the game plan. It's going to happen. So I'm going to grab this x ln 5 and jump it to the other side. Why? Because that'll put both the x's on the right and the non-x on the left. We want to separate out the x's from the non-x's. So coming down to here, I'll have 6 ln 5 equals x ln 7 minus x ln 5. So everybody see what happened? See how that x ln 5 jumped to the other side, became a negative x ln 5? Like that? See how that put both x's on the same side? Now, you can just factor it out. And last step, just divide it. Many will not get that question right on Monday and Tuesday. And if you just watch me do it, but don't try it yourself this weekend, you will be among those who don't get it right Monday or Tuesday. You got to do that on your own a couple times. Practice that on your own. Make sure you can do that. So there it is. There's the answer. Somebody have a calculator? Because they wanted decimals on this one, huh? Anybody else getting that? Yeah. Good. Make sure you can do that. A lot of people get messed up. Because remember, when there's more than one item in the denominator, you got to parenthesis. Well, depending if you have the old kind of calculators that lays everything flat, you got to put parentheses around that denominator. Oh, and the numerator has two things also. Yeah. So if you have the old kind of calculator that lays everything flat, then you're going to have to parenthesize the numerator and parenthesize the denominator. If you have the newer kind that make it look like a fraction, then it's fine. You can just do it like it looks, it'll be fine. But make sure you can get that answer, 28.7. Is that good? Questions on that? Okay, so write as a sum or difference of logs. So they want me to take this one log and make it many logs, right? Logarithms, sum or difference. They want me to make one. Basically, I'm just using the properties here. Making one log into lots of logs using the properties. So how can I use the properties to make that one log into a lot of logs? I'm just going to crank it out. So it's 17. They're all going to be log 10, log 10, log 10, right? The base doesn't go anywhere, right? That 10's just glued to the G. Log 10, log 10, log 10. Root x minus, see the y ends up subtracted because it's on the bottom, right? Remember how dividing is subtraction, multiplying is adding. Remember those properties? It's the easier operation for many logs. Adding, subtracting for many logs, multiplying, dividing for one log. Last thing is what? What do you do without root x? Yeah, root x is x to the half power. Remember that? A root is a half power, and you know where powers go, right to the front. So it becomes log base 10 of 17 plus a half log base 10 of x minus log base 10 of y.
We don't have to write out the base 10, right? On all of them?
Oh, right. Yeah, it's not required, huh? Because it's understood to be 10 if you don't write it. Good point. Yeah, exactly. Good on that one? Let's try number 10. Express as a single log. So take number 10 and make that one a single log. All right, first off, that half, that's just half in front of parentheses. There's nothing logarithmic about that, right? That half is just needs to distribute. Boom, boom, right? Nothing magical there. Half log 7, x minus 3 minus a half log 7x. Good so far. That was just simple distribution, like from your algebra days, right? That half was just sitting in front of parentheses. It just needs to go to the front of each of those logs. So far, so good. Now what? Supposed to make these into one log. What am I going to do? Yeah, division. What is this half power going to do? Oh, I'm saying it, huh? The half in the front is going to go to the power, isn't it? It's going to go to the power, right? Numbers in the front go to the power. So it's going to become log 7. So it's going to be a root of x minus 3 over a root of x. Done. Or you can make that one big root. It's the same thing. Either way. I'll say or. Log base 7, one big root. Same thing. This or this. Right? The subtraction became division. The halves in the front became roots. Right? Half power's a root. We made them one log. So just number 9 and 10 are testing the log property knowledge. All right, good. I'm going to move it on to number 11. Okay, number 11. Using graphing calculator. So it actually says you're supposed to use your graphing calculator. What do you do? How do you use your graphing calculator? On this one. What do you do? Left side's y1, right side's y2, do the intersect thing. Now, that's easier said than done. A lot of people missed, I think, needless questions on exam 2. Graphing calculators. Hit the buttons, but I know it's hard. It's even harder than that, huh? Because when you graph it, sometimes you see nothing, right? So you know how to deal with that, I hope, right? I've sent you YouTube. I've talked about it in here. I feel you should know that, and I will test on that, right? So y1 equals ln 3x. y2 is negative x plus 3. Type them into your calculator, right? Hit second, well, graph it first. Man, put them over here. y2 is minus x plus 3. So graph them, and then hit second, at least on the TI-84, the Casio's a little different, the TIs. So hit second calc, and choose the intersect routine, and just hit enter 3 times, basically. Enter, 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 and you should get an answer. Assuming it's on the screen. Is it on the screen? So if it's not on the screen, what do you do if it's not on the screen? You write a note. If not on the screen, you need to change the window, of course. That means you're looking at the wrong window. Like maybe the graph's way up here and you're looking at a window below it or something. But how do you know how to change the window? You hit second table and look at the y values and then change your y min and your y max especially on your window. Right? So I sent a whole YouTube about that to your guys' email, whatever email you put into Math Excel. I sent, that was like 2 months ago or something. I sent YouTube about it. That was a discovery for me this semester. That guy had a great idea. So if you ever graph and you're seeing nothing, then hit second table and it'll show you the XY table that it's making to graph. And you go, oh, those Y values are up there at 1,000. My Y window's only going up to 10. No wonder I'm not seeing anything. Then you go back and you change your Y max to cover those, to be beyond those. If they're going up to 1,000, you go up to 1,100 or something. You know, go a little more so you can see the graph. Maybe go to 2,000 or 1,500 or something. You know, just keep fiddling with it. But hit second table, look at the Y values, and change, and then graph again. So once you got it on the screen, just hit second calc, intersect, enter, enter, enter. What's the answer on this one? 1.49, blah, 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 huh? Anybody else getting that? Yep, good. All right. Let's do number 12. So grab me after. If you're having trouble with your graphing calculator, just take 10 seconds afterwards. Be glad to help you. Just stay after and grab me. All right, let's solve this one. How do we solve that thing? Let me give you a second to do something amazing with that one. See what you remember. Countdown, right? We count down the logs. So 2 logs. So it's 2 logs, 1 log, no log, right? So how do the 2 logs become 1 log? Adding becomes times. What if that was subtraction in the middle? If that was a minus in the middle, I would put x minus 1 over. I would divide the 2, right? Subtraction becomes division. Adding becomes times. Okay, so that's 1 log. So 2 logs in the first line, 1 log on this line. Now no log. Lose the log. What happens when you lose the log? Base stays the base. The other 2, so it's the fundamental, I call it the golden log rule, right? We use it all the time. The base stays the base. The other 2 switch. Instead of 3 to the x stuff, it's 3 to the 3. And the x stuff goes over there. No logs. Right? Remember that? All right, what is that? That's 27. Foil this out. Now you just solve it. X squared minus 7x minus x plus 7. What are we going to do with that? What do you do when you got an x squared equation? Get a 0. Right? As soon as you get x squared, if you got x squared, get a 0. And then factor, huh? So get a 0. So subtract 27 from both sides. That's 0. This is x squared minus 7x minus x is minus 8x minus 20. We good to there? Right, this is minus 7 minus 1, made minus 8 there. Okay, and then factor that further. What is that? 2 and 10? 2 and 10. Sign in the middle. Sign in the middle always goes on the bigger. Right? The 10 is bigger than the 2. Sign in the middle always goes on the bigger. Right? So, but then the answers are the opposite signs actually, huh? So the final answers are what? Negative 2 and positive 10. Because, you know, you would set each one to 0 and it would move over. Now, are those both keepers? No. Cross off the minus 2. Because if you put a minus 2 back in the original, he would make the inside of the logs negative. You can never, no answer with a log can make the inside negative. So the answer is only the 10. Good? Remember that? Questions on that? All right, number 13. Find the effective rate of interest. How do we find the effective rate of interest?
Use $1 as
Yeah,
a year.
that's right. Put in $1 for 1 year. And then at the end, we'll take your answer, I should say. Take your answer and subtract the original dollar. And you got your answer, right? Remember that? So give it a go. Into what? What am I plugging into? Well, it's compounded monthly, so I'm going to use the P1 plus R over N to the NT. Right? If it was continuously, I'd use the PERT, wouldn't I? Okay. Plug in $1 for 1 year. Let's do it. So let's put in principal $1, time 1 year. So here we go. So the amount is going to be 1 times 1 plus the interest rate is 6 1/4% is 6.25, right? A quarter is 0.25. Change that to a decimal, 0.0625, like so. Right, we good there. Over N. N is monthly, so 12 to the 12 times 1 year. All right, hit the buttons on your calculator. Somebody got that? 1 point. Give me one more.
1.2.
Is that right? 064,322. You guys getting that?
That's what I got.
Anybody else getting that?
Yeah.
Yeah? Okay, so then what do we do with the answer? You take the answer and you subtract the original dollar. Because you just want to know the growth, right? The original dollar we already put in there. Get rid of that dollar in the front. And so the growth is 0.064322. Change it 2 places. 6.43 hundredth. So just 6.43%. So what that means is 6.25% done monthly. The real effect is 6.43% done once a year. That's the annual percentage rate. That's what it really does in a year. Good on that? Questions on that? We got to look. Okay. Let's try that one real quick. Spotlight has a parabolic cross section, 6 feet wide at the opening, 2.5 feet deep at the vertex. How far from the vertex is the focus? Remember how we do these? You just put it on a made-up axis system. Spotlights don't really have an axis system. We just make that up to help. They're saying it has 6 feet wide at the opening. So that's 6 feet wide at the opening, 2.5 feet deep. This is 2.5 feet deep. They're saying, where's the focus? Somewhere like right there, right? We want to find that focal point. Where should they focus? Like if you're making a satellite dish, where should you locate the receiver? If you have a 6 foot wide opening, 2.5 feet deep. How do you find it? So what's the equation? Remember, what direction is this parabola going? Positive y. Remember, the first power letter goes with the direction. So that's going to be positive 4ay on the right side, right? On the right side, x squared. That good? Now you could have made this parabola dish going to the right and done a different equation and made that all work too. We're just making up this axis system thing, right? They don't really have an axis system. We're just doing that to help us out. All right, so we got to find a. Whoops, I'm just writing the equation again. All right, so what do I do to find a? I got to know this point here, right? What's that point? Over 3 up 2.5. Because it's 6 total, right? So this is 3. And this is negative 3, right? So it's over 3 up 2.5, this dot right here. So put in x3, y 2.5. So 3 squared is y, 4a 2.5 squared. That's 9 is, I don't know. What's that? 6.25 times 4 is 25, I think. Divided by 25. A is 9/25. That's where the focus goes. Up 9/25. Not very high. There we go. Kelton. I have no idea. I'm just totally wrong. I'm crazy. Yep. Let's try again. So this should be 9. And that should be some other number, not 6.25. Here, let's try this again. Keep backing up. 9, what's that, 8, 10 now? 10? And then divide by 10. There we go. How about 0.9? That's a little better. There's where the focus goes. All right. Good. I was testing you. Well done. All right. I'll see you Monday. Have a good weekend.